Okay, here's our video on the LCM, and the LCM just means the least common multiple. So here's a multiple, 12. 12 is a multiple of all these numbers you see on the right. 2, 3, 4, 6, and 12. These are all the factors of 12, and 12 is the multiple. So if I wanted to compare two numbers, like what is the multiple of 4 and 12? Well, the lowest number that 4 and 12 both go into would be 12. But there's a way that we can get the lowest common multiple. We can use the box method, and we can use something called the tree method, or creating factor trees. So we'll do both in this video. So let's look. Let's say that we wanted to find the LCM of, let's say, 5 and 2. So we can make a box. So I'll make a box for you. And it doesn't have to be perfect. And just list the multiples. So, and if you want, you can put numbers up here, 2, 3, 4, 5. That is just showing you that we're multiplying by 2 times 3 times 4 times 5, and so on. So you'll get something like this. And you can keep going if you need to. And the same with 5. 5 times 2 is 10. Now I can stop there because we see a common factor. A common multiple, that is. 10 is the common multiple. It's the lowest common multiple. Again, you can keep going. You can get other multiples, but you want the least common one, and that is 10. So the least common multiple of 5 and 2 is 10. 5 goes into 10, 2 goes into 10, and that's the lowest number they both go into. Okay, let's do another example. See if you can do this one on your own. Using the box method, we'll find the LCM of, let's say, 12 and, let's say, 18. Try that. I'll make the box for you. Put 12 here, 18. And again, you're just multiplying. So try that and see what you get. Okay? So again, we just multiply times 2, times 3, times 4, times 5, times 6, whatever we have to do. So we have 12 times 2 is 24, 12 times 3 is 36. All right? And with 18, 18 times 2 is 36. I can stop right there. The LCM of 18 and 12 is 36. The lowest common multiple. 12 goes into 36, 18 goes into 36. And that's the lowest number they both go into. So that's using the box method. There's another method we can use. It's called the tree method, or creating factor trees. And we did that with when we got the GCF. It's almost the same way. So let's put 12 up here and 18. We'll find the, and we know already that the LCM is 36. So what we do here is, like we did for the GCF, we're going to get the prime factorization of each number. So the prime factorization of 12, we can do 6 times 2. You could also do 4 times 3. Don't do 12 times 1 because you're not really accomplishing much if you do 12 times 1. So 6 times 2 or 4 times 3, whatever you want to use. Circle when you have a prime number. So 2 is prime. 6 is not, so keep going. 3 times 2 and circle. So circle all the primes. And we'll do the same with 18. Do 9 times 2. We circled the 2. And the 3. 3 times 3 is 9, so there's our prime factorization. Now, unlike the GCF where you compare, you line up both of them, with the LCM you want to find out who has the most of each factor. Like, who has the most 3's? Well, 18 has the most 3's. 12 does not have the most 3's. 12 has 1 3. 18 has 2. So cross out the one that you're not going to use. You're only going to use the 2 3's. And one way to make this easy for you is if you create a box of the numbers you're going to keep. A factor box. Right? I'll put it over here actually. Right? So we're going to keep these 2 3's, and 3 times 3 is 9, so we can just put a 9 in the factor box. Now, who has the most 2's? 12 has the most 2's, so we can get rid of this 2. Remember, we're only looking at the circled numbers, the prime numbers. So 2 times 2 is 4, and 9 times 4 gives us our LCM of 36. It's the same number we got when we used the box method. So let's do this again, using the tree way to find other numbers. Now remember, you can use this for 2, 3, or 4 numbers, or more. Sometimes it's easier to do the factor trees, especially when you're getting into large numbers. So let's try to do this with the tree method. Find the LCM. All right, we'll do 14, and let's say we'll do 14 and 20. So try to do that. Pause the tape and try that. Okay, make a line down here. Well, 14, we have 7 times 2, and they're both prime, so we can circle them both. We'll create this big factor box over here where we're going to keep our numbers. Put that over. 20, we have 5 times 2. Excuse me, 5 times 4. And 5 is prime, but 4 is not. Break down the 4. 2 times 2. Now, who has the most of each factor? Who has the most 7s? Well, only 14 has a 7, so we'll keep that 7. Who has the most 2s? 20 does. We don't want that 2. So 2 times 2 is 4. And who has the most 5s? 20. There's only one 5. Okay, and just multiply 7 times 4 times 5, and you'll get 140. That's the LCM, 140. So if you took 14 and 20, and you wanted to find a common factor, you have to go all the way to 140. Now, we can also do this with 3 numbers or 4 numbers. See if you can do this with 3 numbers now. Let's say I wanted to find the LCM of, let's say, 12, 10, and let's say 8. 12, 10, and 8. Do the same thing. Make factor trees and keep those with the most factors. So pause the tape and try that. Okay, with 12 we have 4 times 3 or 6 times 2 that we want to use. Don't forget to circle the prime. And 4 is 2 times 2. So now we have all the primes there. And you should double check. 2 times 2 times 3 is 12. With 10 we have 5 times 2. Both of them are prime. We can circle them both right there. And 8, well, I know 2 times 2 times 2 is 8. And we can circle all those primes. Again, what do we do next? We make our multiplication box. Who has the most 2s? The 8 does. So we don't want those 2s, and we don't want that 2. So we're left with just 8, because 2 times 2 times 2 is 8. Who has the most 3s? The 12 does. And who has the most 5s? The 10. So we just multiply 8 times 5 times 3. And we get an LCM of 120. Okay, so we've done the box way and the factor tree way, well, just a tree method. In the next video, we'll talk about more of the LCM, what the LCM is with word problems, and we'll do some more box method and tree method. Great job.